Good morning, everybody. I am CR Oldham. Introduce me. I'm a platform engineer at SaltStack. I work with Tom and Justin, a bunch of those guys. Great place to work. We're actually hiring if you're interested. You can come over and write Python, hack on cool stuff, and on occasion even have snacks. So my presentation is Where's the Waldo? So does anybody know what the original name for Waldo means, what that was all about? A Waldo was a feedback device by which you would insert your hand into it and you'd be able to control something else. And the name actually came out of the Muppets. If you've ever looked over the Muppet wiki, it talks all about how they developed a lot of this technology for remote control. So why am I talking about Waldos today? Well, that's kind of what Proxy Minions are about. It's kind of reaching through an existing minion to control something that can't run a minion. Now, I'll warn you, this could very well be a crash and burn presentation, and I'll explain why in a minute, but mostly it's because it depends on a lot of moving parts that are being modified by a lot of other people, some of whom don't work at SaltStack, so I don't have a lot of control over what they do. But anyway, I hope that when we're done with this, the purpose is to show you how you could actually build a proxy minion to control something that can't run a minion. And we're starting with network devices. So we've been talking with Juniper and Cisco and some other network companies to bring this functionality in. You know, how many of you are like network folks here? Okay, and how many of you are like developer guys? Okay, so I know when you get developers and network guys in the room, sometimes it's kind of like matter and antimatter. You know, because they come from two totally different worlds. You know, what we're seeing a lot in the industry is kind of bringing some of that DevOps mentality into the network area, and I think it would be totally cool, really awesome if you could actually have salt stakes that would bring up your data center network. And when you want to make changes, you know, you go into the state file and you say, okay, you know, this VLAN is to point here, and you type, you know, salt data center state.high-state, and you're done. We're not far from that. We have a lot of work to do, but it's within our reach now. Then your entire network gets documented the same way, you know, maybe your rollout of a particular application is documented. So anyway, just a little bit about me. I've been in IT my whole life. I have a couple of degrees in computer science. I used to work for a accreditation organization. I was director of IT there. I went from there to Marvell Semiconductor, and then I moved here to Utah and started a nonprofit called Hope Kids, which you may or may not have heard of. Hope Kids works for families that have kids with cancer and other life-threatening medical conditions. And I was there for 6 years, and then kind of got burned out and remembered how much I love technology. That was really my passion. And I was on IRC one day. I don't know if you know Dave Boucher, and Dave's like, we're going to move offices. And I'm like, oh, really? You know, should I send a resume? And he was like, yeah, I just sent it to jobs at SaltStack. And I thought it'd go to HR, the HR black hole, you know, and I'd never see it again. But the next day, Tom calls me and he's like, yeah, we'd like you to come in. And a couple weeks later, I was on board. So Hope Kids is doing great. They have a new executive director. She's doing a fantastic job. I met with her last week. She's like, I don't know how you ever did this. I'm like, I have no idea how I did it either. So, but basically, the last bullet point, you know, sums up myself and probably most of the people in this room. If there's a keyboard and a monitor, give it to CR. They'll take care of it. So that's been my whole career. Who uses Salt here? Okay, so I'm gonna do the quick 3 to 4 slide introduction, so those folks that don't use Salt kind of get an idea of what's going on. It's, you know, Salt plays in the same arena with Puppet and Chef and Ansible, those things. We're more than just configuration management, though. We make up what we like to call a unified system control platform, or a remote control, remote execution framework that also does a significant amount of automation. And obviously, if you're here, you're not in the talk with Tom is talking about our network protocol that we're building called RAID, which is going to help with some really phenomenal automation stuff. And I want to move that into the network arena too, you know, where you can do things like, and I know the existing products already do this, but you can do it with Salt, where, oh, our primary WAN link fell over. Well, what do we do next? Well, Salt could pick that up, fire a reactor event to go do whatever needs to be done to bring up the backup link. Those kinds of things.
Will it move cables?
Well, back here, see that's all about, right? No, seriously. So, we do remote execution, job management, state discovery. We can provide kind of a control and you control and view like all aspects of your environment from your Salt master. It is actually really simple. It's designed to be simple. It is really easy to set up and use. That's kind of something that we've been working on kind of in the industry where we're really easy to set up. I mean, you can, and I actually run Salt on my home network. I've got like 6 Macs and a couple of Linux boxes and stuff. And I'm able to push out patches, the packages that come from Apple rather than wait for my kids to figure out, oh yeah, I really should click update. I can push that all out to Salt. It's so much easier. And it's easy to dive in and get started. Like I mentioned, Salt's we're founded on remote execution. You can send server commands all around your infrastructure. Right now we use 0MQ for the transport. Like I said, Tom's talking about rate in his session right now. Oh, keep going.
Yeah, is that wire long enough for you there?
So we've run up against the limits of 0MQ. 0MQ is really neat. The guy that built it is very, very smart. But we're just kind of pushing the limits of what you can do. One of our customers is LinkedIn. They have 10,000 nodes and in a single data center. And they've got 3 different data centers. They drive it all with Salt. And every so often 0MQ just kind of falls over. We're all about doing stuff as fast as possible in parallel so that you can get stuff done as quick as you want to. And like I mentioned, it's not really just for large infrastructures. It can scale up or down as far as you need to go. Home networks, micro networks, Arduino, Raspberry Pi, BeagleBone, dumb devices like switches and routers, which we're going to talk about a little later. Coffee makers, sprinkler systems, And the other thing, which I think is really cool, one of the other guys in my office is talking about building proxy minions for Google Apps, where you could, if your company uses Google Apps for your email and stuff, you could drive all that with Salt. So really anything with REST API, which we're going to look at in just a minute. So just some examples. Targeting by range, do a package upgrade on all your machines that run Ubuntu. Bonus points for what the middle two mean. Recent thing in the news. Heartbeat. So Justin Wave is like, you want to tell your story real quick, what you did with Salt.
So we had my team's infrastructure is all in Salt, and when I heard the news, I hopped on and I ran a command to test which servers had the heartbeat problem. It took about 5 minutes to figure out the command, and then I told it to update, and I went to bed. And then the other team that didn't have that all installers operate and all their systems spent 2 days upgrading their infrastructure. So what I did in 5 minutes before bed took 2 days.
And how many boxes was that?
I only had maybe 20 or 30.
Okay.
But that's still 9 minutes of pain.
Yeah, definitely. Set the root password on all your machines. Obviously that's a hash, that's not a password. And so some state examples. Salt is divided into what we call execution modules and then states. So states let you describe the state of your infrastructure. This is almost right out of a deployment state that I wrote last week for deploying an internal application that we have. Make sure the web directory's been created, check out the project from Git, using a deployment key, but first make sure that the deployment key is actually where you expect it to be, and it's just now one command, Salt, thorium state to high state, and the project gets deployed. So, all right. Minion to master communication. So the way Salt is architected is each minion runs a Salt minion process, and each controlled device, controlled server or whatever. It's written in Python, so there's a runtime there. It's about, resident set size is about 30 megabytes. Obviously that'll change depending on what you load in there. But by default, if you fire up a minion and you don't have a lot of state modules there and stuff, it's going to take them about 30 megs of RAM. And then the minion connects to the master, which is different than most other configuration systems where you've got like a control node that goes out and connects to all the machines that you want to control with it. And then obviously minions connect to the master, and then the master controls the minion. So which kind of brings us to this question. So what if the devices we want to control, we can't spare 30 megabytes of RAM? I mean, like, let's say the old WRT54Gs had 32 megs of RAM, I think.
That's the GS.
Thank you. The GS had 32 megs of RAM. Well, you can't run a minion there. I mean, and later versions of that didn't.
You couldn't even install Python.
Right, exactly. So that's where the proxy minion comes from. Either there aren't enough resources, or you're like, some companies don't really want to run, this extra agent on their stuff. They didn't build that agent. They don't know, what it's going to do. Maybe it's going to run wild and crash your whole router or whatever. So here's the entertainment portion.
Girls, come on, you munchkins! We've been spotted. Come get us!
So we call them minions, right? That's our Despicable Me references are getting a little bit old. It seems like every time we have a presentation, we talk about one of my favorite movies. So a proxy minion, essentially, all it is a process forked from a regular Salt minion. And its sole purpose of that process is to talk to the device that can't run the minion. That's really all it is. Okay. So in this case, to extend the analogy, crew would be the Salt master, and there's a Salt minion, and those guys are the proxy minions, and then the car is the proxy device. So in other words, crew picked up the phone and said, "Come get me," and the proxy minions picked up the call and got in the car and drove the car over. So, and like I said, where I hope we're going eventually is that you could bring up your whole network with Salt like this. It's going to take a look. So aren't there other tools to do this? Sure. Yeah, you can do it with the web interface. You can do it with SSH. You can do it with the CLI tool, the virtual shall remain nameless, that really competes with us. But in general, we think Salt would be the best way to do that. And one of the reasons that this came about, so who manages Juniper devices? I know Cisco does this too. Anybody manage Juniper devices? Okay, so you load the configuration and then you got to commit it, right? Well, a lot of other tools that are trying to drive network devices can't do that. They open a connection, they send a command, they close the connection. And then Juniper, if you close the connection, what happens to your configuration changes? They just go away. They don't get committed. But because of the way that Salt works, we can bring up this persistent connection. We can do that batch load or whatever. We can check it and we can commit it. And of course, bootstrapping SSH connections over and over, that can be slow. And Juniper needed a persistent connection to overcome that particular issue. It was taking them a long time as they were testing Ansible and some of the other SSH-based tools, which is one of the reasons why they came to us. So this diagram is really hard to see. I'm sorry about that. But this is just kind of an overview of what it might look like if you were to draw it out, where maybe you've got 3 different minion controllers, 3 different machines that are going to run these minions for you, and each one of them forks off maybe 3 proxy processes to control set network switches, maybe some dumb devices, maybe I've got just an SMS serial GSM modem there to send text out, those kinds of things. So but essentially this is kind of a better image. So the master, this minion fires up, connects to the master, and then minion forks the proxy. The proxy itself connects back to the master, and then the proxy controls the device. So that's the idea behind it. Okay. So if you want to build a proxy minion, how do you do it? So anybody who already uses Salt knows that you can put custom modules in your Salt directory to get pushed out to your minion. And also grades can go in there too. Well, now you can put an interface package in _proxy in your Salt directory or wherever you define your file groups to be. And that will get pushed out and run on your minions for you. And we're going to look at some of that code in a minute. So basically, a proxy minion needs an interface package. It's a Python package that handles managing the connection. And that package has to have a class in it called ProxyCon, and that class has to have 1, 2, 3, 4, those 5 methods. It needs an init, it needs a method called proxy type that just returns a string that tells you what kind of proxy it is. It needs an ID method that returns your minion ID. It needs a ping method, and it needs a shutdown method. So that's the bare minimum for building a proxy minion. Okay, so like I mentioned before, Salt's based on execution modules and states. The thing about proxy minions is some execution modules will just work. Some of them don't make sense. You probably don't want to load packages on your coffee maker. Some modules need a lot of work to make them work with a proxy. So right now, kind of that hacky way around this is modules that are supposed to work with a proxy have this dunder variable set in them called proxy enable, which can either, it needs to be a Python list, and it can either contain just star, meaning this module works with everything, or a list of proxy types that it works with. And I know that's ugly. There's got to be a better way to do that. In general, the proxy minion stuff is still really alpha. I put it together. It became kind of functional in January. I haven't had a lot of time to work on it since then. There's a billion devices out there, and there aren't that many people at Salt. So if anybody wants to try to build a proxy minion to drive a particular device, I'd love to talk to you. That would be awesome. Because there just aren't enough of us to make this work over time. So, let's see. Oh yeah, so buyer beware. So some things that don't work very well right now that I want to enhance in the near future is process management. How do you know how many proxy minions your minions are running? Logging needs to be made a little bit better right now, just because it's a fork. The logging is the same as for the proxy as for the minion that forked it. So all those logs just go into your log file, and you're like, I'm not quite sure what I'm talking. Which process is throwing these errors. If you use Salt in masterless configuration, this doesn't work in masterless configuration at all. And in general, there are lots of things that are broken. Most of the execution modules just won't work until they get that proxy enabled directive. So let's see. All right, so that's my contact information. That's actually in my slides. I wanted to show you some code and some stuff that hopefully will work. Okay. You guys read that? It should be there.
Let's go.
I can read it back here.
Okay. All right. Okay, so what I've got here is I have a virtual machine running Ubuntu that runs a salt master and a minion. And then I have, I've got this process over here that is just a really, really simple website with a REST API, which is that. So this is like mimicking, it's mimicking something out there that has a proxy on the other end. And this code is actually in GitHub. I built this specifically to make so you can have a really easy way to see how can I build a proxy minion. Okay, this is how it would work. So this is just like a fake machine that's got 3 services and 1 package installed right now. So let me go back here to this terminal and so what I'm going to do right here, I'm going to start the proxy minion so you can see what shows up in the debug log. So you kind of know what to look for. Okay, so here's what you'd see in the debug log. It says, I am rearing 64, in other words, that's the minion ID. And I need to start some proxies for rearing 64. And then here's the 2. So we've got 2 proxies running here. I've got one called REST sample, which is that REST interface. And then I've got one called Junos. And so those processes have been forked. They're running in the background. And actually, let me just pop over here so you can see. That's really tiny. So this is actually, for you guys that know Juniper, Juniper actually publishes a virtual machine with running copies of Junos. So that's running in a virtual machine here. And then I've got those other proxies. So let's see what Salt can tell us. Okay, so I've got, Salt tells me we've got 3 machines that it's controlling. Well, actually, they're all the same machine, right? So this is rearing 64, the actual Salt machine that's running the master minion. And then there's these 2 others. Well, so part of the reason we built the proxy minion the way we did, when we first started out trying to say, how are we going to control these network devices? I wrote just a module, just an execution module. But what do you lose if you just use an execution module? You can't do targeting. You don't have grains. You don't have the reactor. You don't have 90% of what makes Salt really cool. You just can't get at from just an execution module. So that's what led me to think, well, what if I just fork the minion process and then let that fork process talk to the device? Well, then that would make it so that that device looks like just another minion to the master. And you can do everything you need with it. So for example, let's look at the grains. Grains items. Okay. All right. So, and that's another thing. Grains are actually kind of I don't know if you ever looked at the grains module that calculates grains. It's a nightmare. I mean, because we look at all the different OS configurations and all that stuff. So, but again, that stuff doesn't make a lot of sense for a proxy because a coffee maker, what's it going to tell you about itself? I'm 10 cups, Mr. Coffee. So for this one, I just built grains for the REST sample, just goofy stuff, house cat, kernel, location. So OS, that's the important one, REST example OS. And then OS family is proxy. So OS family is proxy for every proxy minion out there. That's kind of the defining key if you're trying to target by that stuff. And then for Junos, this may very well break. Let's see what happens. Test 99 is the name of that Junos device. Oh yeah. So I put these grains together on purpose because it kind of demonstrates how, if you had a bunch of switches, for example, in a data center, you could define location for them, and then you could target all those switches based on location. Here's version info. That comes right out of Genosys Facts Dictionary. But this is pretty cool. I mean, say, well, yeah, we're having some issue in this data center. Let's just attack all the network devices in the data in that particular data. And then, of course, you can do the normal stuff like test.ping. So it's true. You can target by grain. Let's see if I can get this right. OS family. Proxy. Test.ping. Yeah. I knew at least one thing would break. Probably more will break. Okay. So let's look at the REST sample. All this is right here is just, it just keeps refreshing every 5 seconds in the background. It just so what we can do from the proxy here is, actually, let me show you some screens first. All right. So this is a state file specifically for that particular REST service. So you can go over here and say salt state.sls REST packages. There we go. Okay. So what does this tell us? Okay, so it killed Apache, and Postgres was, it probably needed to be started. It just said it was already ready. So now if we go back to this web interface, you can see that something else is broken. All right. Let's try that one.
Say that again, 276.
Yeah, definitely some work to do there. Let's see if the package stuff works. All right, you have to take my word for it. And apologies for that. But I did want to show you some code here. Okay. That's the module. Gotta find the. All right, so this is the actual interface module for interfacing with the device. So obviously, we've got to, we need some third-party libraries. There's a guy at Juniper named Jeremy Schulman who's built a really nice Python module for accessing Juniper devices, and that's what that is. It's called PyEZNC, I think, and it needs NC client for Netcom. And he layered all this cool stuff on top of it. So here's the proxy-enabled directory, proxy-enabled variable, which actually, it works for execution modules, and it works for, the loader looks for that in execution modules and states and in the proxy modules to know exactly which proxy it refers to. And here's the proxycon object. And so in the init, this is where we bring up that connection to the actual device. So we define it, and we open it, and then it sits in this variable called device. Here's the proxy type variable that returns Junos. Here's the ID, which just brings that right out of the facts dictionary for the host name. Here's the ping method, and I was playing with this earlier today, just to have the device print out its routes, and then here's shutdown. So those are 6 methods there that I defined, 5 of them that you have to have in order to build a proxy minion. And then if we go look over here at the execution module, actually pre-alpha quality, I guess. Same thing here, we need to get these items. For execution modules that can rename themselves, for those of you that know Salt, you target the package manager with PKG, but depending on what OS you've got, it could be RPM or Yum or apt-get or whatever. So that's what virtual name does. This refreshes the facts. So all that does is after the proxy gets bootstrapped, then in the Salt ops dictionary, you get this entry called proxy object. And so every time we want to access the device or do whatever we need with it, we just treat that like the object that it is. And in the device variable, we call that the facts refresh method in there. And then we return this message. So there probably needs to be some better error checking there. In case for some reason the facts refresh didn't occur, then that shouldn't say refresh. It should say I'm on fire here. Please help me. Routes. So this maps directly to this call right here. And set host name, this actually does not work with the current version of the EasyNC Python module. I need to fix this, but that was the idea where, okay, let's set the host name. Here's the proxy object, if it's none, let's ignore it. Otherwise, construct this string and then just load that into the configuration and then commit it if you want, or if you passed false here, don't commit it yet. So that's kind of the methodology behind making changes on the switch or the router or whatever it is. And then we've got a commit method here, and then a rollback method. And then Juno supports diffing to configurations, so we just return that diff if you want to look at what's in place versus what you're about to commit. And then this actually is not related to the ping method in the other module. I was writing this to see how maybe we could just get some uptime out of it. So, not a lot there. And obviously, configuring switches and routers is a lot more complicated than this. But this is just kind of a basic start. What could we do to at least maybe enumerate the devices we have out there, or give us a little bit of information about it? Jeremy and I have also been talking about things like helping organizations manage support contract life cycles with this, where you could go out and say, okay, Salt, show me all the when are our contracts going to expire? We could shove that information in there somehow. That would be interesting. So let's look at the REST sample. There's that. Okay. So here's the proxy con for the REST for the REST sample website there. So it doesn't maintain a persistent connection because it doesn't need to, and that's not the way REST works anyway. So all we do in the init method is just grab the URL that we're going to contact, and then we also cache the greens here, which is kind of handy. And to get the ID for for the proxy, we just do a get on /ID, and we return that. To get the grains, we should do a get on /info. To refresh the grains, we wipe out the cache, and then we return the grains themselves. We can start a service by calling service start and the name of the service, stop the service with service stop, restart, list the services, service status, service available, and then installing packages, which didn't want to work for me earlier. And then obviously you don't need to shut down because the connection isn't persistent. So just kind of a little overview of what it might take to build those things. So that's the ProxyCon object. And if we go over here and look at yeah, so there's only two methods in this execution module, refresh and ping. And ping does work. Returns true. Services. All right. So supporting services in the REST example. This is the execution module for services. So again, all it does is go out to the proxy object and call this method that was defined in the object. So that makes it real easy to add stuff. As long as your proxy object supports it, you just define a method to do whatever you want. I think, let's see if I can just call this. Yeah, okay, so now that part works. It's just the states that are weird right now. So you could start them by hand. Start Postgres. And now it's running. Oh, and I did get the package eventually. Okay. I guess I'm smarter than I look. But anyway, that's all there is to that, really. It's just adding those methods in there. Start, restart, status, available, list services. It's not a lot of Python to write for that. So if you extend that a little bit, think about Google Apps, for example. You wanted to list all your users, well, that's not too hard. There's Python libraries out there for accessing your stuff in Google Apps now. So you could go into Google Apps, just say list my users, turn users on and off. It would be kind of handy. And that would enable you to tie that stuff to other things in your infrastructure, right? With Reactor, for example. Let's create a new user. Okay, oh yeah, well, we created a new user in Google Apps. Well, that fires this event. And that event would go out and create related users in whatever other systems you got. So, okay. And okay, and let's see. Oh yeah, so let me just show you the code for the actual REST service that's running there. Yeah, so it's just done with bottle. And all it does is the process just maintains these, it's really simple, it maintains these dictionaries inside of it, and calling the different REST routes just messes with those particular dictionaries. Just as something, okay, what's pretty much the simplest thing that you can do to help people understand how this might work. All right. So like I said, it's still very much an alpha. So let me bring this up. So that's the QR code for the join-in. So I'll put those slides up there. The code is on GitHub for both the proxy REST, the sample REST API, and also all the proxy minion development is being done in the open. It's not proprietary, so it's all going to get code. And that's how you can get a hold of me if you want to ask more questions, or if you want to build a proxy minion for us to, I don't know, drive something. And I want to spend some time, or at least leave some time for questions, because this is kind of a big topic. And if you have questions about how this might work in your infrastructure, or you've got weird devices you want to control, we've talked about that a little bit. So, questions?
Is anybody in the community developing proxy minions, and if so, what for?
The only ones that I'm aware of right now in the community are Juniper and Cisco. That's all I know about right now.
Okay, and when do you expect this work or to improve or to be more robust?
Yeah, by the next release, which will be Helium 3.2014.6, we should have that. And we're going to go to RC in the next couple of weeks for that. So I just haven't had time to work on it lately. But I'm going to get back to that during the next couple of weeks. Other questions? You're a tough crowd.
Good presenter.
No. Okay. All right. So I'm done. Yeah. Feel free to grab me, or catch me on the internet if you've got things to talk about.